here for your last example, we're going to be finding the zeros of a polynomial function, and it says find all your zeros given that 2 minus 2y is a zero of f. So before we've been given polynomials and we've been able to do the p or q to find some possible zeros and use synthetic division. Unfortunately, we're not going to be able to do it this way. As you know, the more math you do, typically the more difficult it gets. So this is a little more difficult just because we're not going to be able to use synthetic division, but we get to use everybody's favorite, long division. So let's look at a couple things we know about here. If 2 minus 2y is a 0, then so is 2 plus 2i. So what that tells us is if we have this polynomial f of x equals x minus 2 minus 2i and x minus 2 plus 2i, we can find an x squared, so a polynomial that has a degree of 2, that is a factor of x to the fourth. And this would take care of 2 of our 4 zeros. So let's go ahead and find this. So we're going to say f of x equals, and remember, distribute all your zeros through, so really nothing matters, or nothing really changes, but negative plus negative, negative. So when you write our equations, we get x minus 2 plus 2i, and then we're going to have x minus 2 minus 2i. So basically the same as what the first two were. If we would have just dropped the parentheses, they just switch spots. So we want to regroup. We're going to group together our x minus 2's and our x minus 2's, and we end up and have a difference of squares. We have x minus 2, x minus 2. Those are the same terms. 2i, 2i, and a plus and a minus. So we need to FOIL this. So we're going to get x minus 2 squared minus 2i squared. And we get a difference of squares. Woo! Everybody loves difference of squares. But I'm so different. Yeah, difference of squares. So we get x squared minus 4x plus 4 minus 4i squared. Don't forget the square. A lot of you are forgetting the square. Now remember, our I squared, that's just a -1, which changes this into a plus 4. Your new polynomial, degree of 2, that we got from just our two complex roots is x squared minus 4x plus 8. Hey, Bill. Obviously, I'm here too late on a Friday. So what that means is, couldn't we take a degree of 4 here and divide it by an x squared and maybe come up with another x squared that if we divide, or you may be able to factor? If you take an x to the fourth divided by an x squared, you're going to end up with an x squared that you could either factor or use the quadratic formula for? Yes. So let's go ahead and take this polynomial and divide it. So let's do this. Let's do this in purple. So we're going to say x to the fourth minus 7x to the third plus 16x squared minus 8x minus 32, and this is going to be divided by x squared minus 4x plus 8. Good thing I learned long division. So x to the fourth divided by x squared. X squared. So you get x to the fourth minus 4x squared. Sorry, x to the third plus 8x squared. And all of these signs are going to change. negative plus negative. So the first ones cancel, so we end up with a negative 3x to the third plus 8x squared minus 8x. And then we have to take this negative 3x to the third divided by x squared gives us negative 3x. So you multiply those three through negative x cubed plus 12x squared minus 24x. So you change all your signs. So plus, negative, plus, cancel. 8 plus a negative 12x squared is a negative 4x squared plus 16x minus 32. Whew. Negative 4x squared divided by x squared. Negative 4. Ooh, nice. So you get negative 4x squared plus 16x minus 32. Huh. Weird. What's going to happen here? Hopefully we get a remainder of 0. Nice. We get this polynomial right here. So, I don't know. That kind of looks like something we may have factored back in Algebra 1. So let's say that if we factor this, we have x squared minus 3x minus 4 equals 0. X minus 4 times x plus 1. And you get x equals 4 and negative 1. So all of our zeros that we end up with here, we get a large amount. Our zeros are negative 1, 4, 2 minus 2i, and 2 plus 2i. We had a degree of 4, so there are 4 zeros. So what we did was, besides a lot of work, we first took our imaginary 0, even though it only gave us 1. We couldn't put that in synthetic or do a P over Q. Since 2 minus 2i is a 0, that means 2 plus 2i is a 0. So if we plug those into our x minus p, x minus q, you get a polynomial that's a degree of 2. So there's 2 of our zeros. When you find 2 more, you can divide your original polynomial up here by your polynomial found by multiplying your complex roots. You get another polynomial that you get a factor, which is nice and pretty, down to a 4 and negative 1, and include those in your zeros. Alrighty. Hope you guys enjoyed these. I had a great time. I love me some zeros. So I hope you guys enjoy your evening. Polynomial function.